Hello everyone, my name is JOEL FERNANDES. I'm a faculty in physics. I'm here to discuss some of the crash course topics regarding units, measurements, errors and one-dimensional motion. So let us begin with the question number 1. The random error in the arithmetic mean of 100 observations is x. The random error in the arithmetic mean of 400 observations would be. So the random errors are always inversely proportional to the number of observations. So more is the number of observations, less will be the errors. So hence our options becomes option D. Moving on to the next question. The sum of numbers 436.32, 227.2 and 0.301 in appropriate significant figures is. So when we add these numbers 436.32, 227.2 and 0.301, totally we are going to get 663.821. So if you look at the total answer, there are total 6 digits here. But as per the rules of significant figures, we are adding the digits which are having some decimal points. So the answer must contain those many numbers of significant figures in which there is a number which contains minimum number of digits after decimal point. So if you look at the given numbers, the second number, that is 227.2, that has minimum number of decimal digits after decimal point. So the second number has total 4 significant figures. So we have to round it off only to 4. So whenever you round it off, since 1 is less than 5, we can just neglect it. Once again, 2 is less than 5, we can neglect it, and the total answer will remain as a 663.8. That is option number C. The density of material in CJ system of units is 4 gram per centimeter cube. In a system of units in which the unit of length is 10 centimeter and unit of mass is 100 gram, the value of density of the material will be. So we have a formula to convert the numerical value of a given physical quantity from one unit to another unit, as N1 U1 should be equal to N2 into U2. So in the first units, the density is given as a 4 and its unit is given as a gram per cm cube. In the next unit, we have to find out the numerical value N2, but its unit, instead of gram, it is given as a 100 gram, and volume will be cm cube, but here it is not centimeter. Now here it is given as a 10 centimeter, so that becomes 10 centimeter whole cube. So coming to the next step, 4, we have gram per centimeter cube. So N2, this is 100 as it is. I'll write gram divided by centimeter cube as it is. So 10 cube will give me 1000. So strike out, I'm going to get N2 is equal to 40. That is option number 2. A physical quantity P is related to 4 variables A, B, C and D as P is equal to A cube B square divided by root C into D. The percentage error in the measurement of A, B, C and D are 1%, 3%, 4% and 2% respectively. The percentage error in the measurement of P is. Now you can see the display, you can see some formulas. So suppose there is a physical quantity Z which is written as A into B, or if there is a physical quantity Z is equal to A by B, it's called as a product rule, this is called as a quotient rule, and whenever we do the error calculations in Z, so delta Z by Z, this quantity together is called as a percentage error in the measurement of Z. So this will be given as a delta A by A plus delta B divided by B. It is going to work for both cases, product as well as a quotient rule. But suppose the physical quantity Z is given as a product of, is given as a power of another quantity, then the percentage error in the measurement of Z is given as a n times delta A divided by A. Now using these formulas, let us solve the given question. So given physical quantity is P is equal to, we have A cube B square divided by root C can also be written as a C to the power half, and remaining is D to the power 1. So using both the formulas. Let us calculate the percentage error in the measurement of P. So delta P by P, that will become 3 times delta A by A, where delta A by A is nothing but a percentage error in the measurement of A, plus 2 times delta B divided by B, plus half delta C by C, plus delta D divided by B. So this is 3 times. Percentage error in the first measurement of A is given as a 1%, plus 2 times error in the measurement of B is given as a 3%, half into error in the measurement of C is given as a 4%, plus 1 into measurement error in the measurement of D is given as a 2%. So totally it becomes 3 plus 6 plus 2 plus 2, that will become totally 13%. That is option B. Okay, move on to the next question. The area of a square is 100 plus or minus 2 meters square. Its side is. So we know that area of any square, that will be square of its side, and this, if I take the square root on both the sides, so length becomes square root of the area. So that becomes area is given, its physical quantity is given 100 plus or minus 2 to the power half. So we need to be very careful while calculating the errors here. So here 100 is the physical quantity. Directly you can take the square root of 100, that will give you 10 plus or minus. 2 is an error. So whenever we have to calculate errors, we have to use the formula, that is a power rule that just I explained in the previous question. We have to use the power rule. So that becomes half times 2. So that will become 10 plus or minus 1. And anyway, the unit is given as a meters. So that will be the option number 1. Moving on to next question, 6. The refractive index of water measured is found to have values 1.34, 1.38, 1.32 and 1.36. The mean value of refractive index with percentage error is. So if you look at the screen, you can see the formula. So directly I'm going to substitute the formula here. What we are supposed to find out is mu plus or minus delta mu. This quantity is required. But this error, this, if you look at the options, everything is in percentage. So let us calculate mu. Mu is called as a mean value. So mean value is calculated by adding all the observed values divided by total number of observations. That will give you 1.34 plus 1.38 plus 1.32 plus 1.36 divided by 4. So that will give us total 1.35. Now similarly, we have to calculate using the second formula, that is a delta mu. Delta mu is called as a error. So mean error we have to find out, that is 1.35 minus 1.34. You have to take the mod. Errors are always added, errors are never subtracted. So 1.35 minus 1.38 plus 1.35 minus 1.32 plus 1.35 minus 1.36, entire thing divided by total number of trials, that is 4. So we are going to end up as a 0.08 divided by 4. So I'm going to get delta mu totally 0.02. Now let us substitute this answer and this in the main equation. So therefore I'm going to get the final answer as a 1.35 plus or minus 0.02. But if you look at the options, none of them are matching. That is because the error is now in percentage. So we have to convert this error in percentage. So how to convert this error in percentage? So converting, so delta mu divided by mu into 100%. So that will give us 0.02 divided by 1.35 into 100%. That gives us 1.5 1.48%. So error is finally calculated in percentage. Now substitute the error and the mean value in the main formula. We are going to get the answer as a 1.35 plus or minus 1.48. That is in percentage. That is option number 1. Next question. The current voltage relation of a diode is given by I is equal to e to the power 1000 V by T minus 1 milliampere, where V is in volts and T is in Kelvin. If a student makes an error of plus or minus 0.01 volt while measuring the current of 5 milliampere at 300 Kelvin, what will be the error in the measurement of a current? Now let us write the given complex equation, e to the power 1000 V by T minus 1. This equation gives the relation between current and voltage. So if you look at the options, all the options are in physical form. So what is required is DI. DI stands for the error. So this error directly can be calculated by differentiating this equation. But before differentiating, I'll rearrange the equation so that I can write e to the power 1000 V by T, that is equal to I plus 1. So I is already given 5 milliampere plus 1, that will give me total 6 milliampere. I'll take it as sum, equation number 1. Now let us differentiate the given equation. So DI, this should be equal to e to the power 1000 V divided by T. Now using the chain rule, differentiate the power also with respect to V. That will give me 1000 divided by T into dV, where this dV is called as a error in the measurement of voltage, that is given in the question as a 0.01 volt. So let us substitute everything from equation 1. This is 6 milliampere into 1000. Temperature is mentioned in the question as 300 Kelvin into dV is mentioned as a 0.01. So this will become 6 into 10 into 0.01 divided by 3. That gives you 0.2 milliampere. That is option number 3. Moving on to the next question regarding vernier calipers. So question says, in a vernier calipers, 10 smallest divisions of the vernier scale are equal to 9 smallest divisions on the main scale. The length of one main scale division is half millimeter. The vernier constant is, the required quantity is called as a vernier constant, and vernier constant is nothing but the value of one main scale division minus one vernier scale division. So in the given question, one main scale division is given, that is nothing but a half millimeter. Now look at the construction of vernier calipers. Vernier calipers has basically two scales. One is called as a main scale, another is called as a vernier scale. And since the error is not mentioned, the question never says anything about the error, so we have to assume that the instrument is error free. So what is the meaning of error free? The meaning of error free is the 0 of the main scale is going to coincide with the 0 of the vernier scale whenever the instrument is closed. Now look at the given information. Total 10 divisions in the vernier scale are going to coincide with the 9 divisions of the main scale. So this distance is x, here this distance is also x, and up to this line they are going to coincide. But the question never says that vernier has only 10 divisions or vernier has 20 divisions, vernier may have 50 divisions, vernier may have 100 divisions. Nothing is mentioned regarding the vernier scale. What is mentioned is the value of this one main scale division is a half millimeter. We don't know the value of one vernier scale division. So but if you look at this diagram, the x for the main scale is same as x for the vernier scale. So this is 10 vernier scale divisions are going to coincide with 9 main scale divisions. So if I rearrange, 9 by 10 main scale divisions becomes equal to 1 vernier scale division. So we have the value of 1 vernier scale division. Now let us substitute this in the vernier constant formula. So vernier constant will be equal to 1 main scale division minus 1 vernier scale division. So 1 main scale division minus, we have 1 vernier scale division, that is a 9/10 of main scale division. So 9 by 10 mean scale division. So this will become 10 minus 9 is 1. So 1 by 10 mean scale division. So 1 by 10 into 1 mean scale division is given in the question as a half millimeter. So this is half. So this becomes 1 by 20. So 1 by 20 will be 0.05. That gives you option C as the correct choice. Moving on to the next question. The number of particles is given, n is equal to minus d n2 minus n1, crossing a unit area perpendicular to x-axis in a unit time, where n1 and n2 are number of particles per unit volume corresponding to x1 and x2. Find the dimensions of d, called as a diffusion constant. So let us rearrange the equation and write it in terms of d, since we need the dimensions of the quantity d. So d can be written as a minus of n. We have x2 minus x1 divided by n2 minus n1. Now if you look at the statement of the question, n is nothing but the number of particles crossing the given area per unit time. So per area per time, so its dimension will be L minus 2 T minus 1. Next, this x2 and x1 are nothing but positions. So their dimension is only L divided by n2 and n1 are nothing but number of particles per unit volume. So their dimensions must be per unit volume, that is L minus 3. So total this becomes L is minus 1, that will go to the numerator. So if we solve this, we are going to get L2 T minus 1. That will be the dimension of D. That gives you option number C. Let's move to the next question. Question 11. If L, C and R denote inductance, capacitance and resistance respectively, then the dimensional formula for C squared L R is. So we have given quantity C squared L into R. So what I will do is, I will multiply this with L divided by L. So this question becomes a C squared L squared into R divided by L. Let me take this equation as a 1. Now suppose you look at the equation of an oscillator. We have the frequency of oscillator as a 1 by 2 pi root LC. So reciprocal of this frequency is nothing but the time period. So if you look at this time period directly proportional to root LC, so this implies that dimension of root LC must be same as a dimension of time. Now suppose you look at a LR circuit, the decay of current in an LR circuit is given as a I is equal to I naught e to the power minus R by L into T. So since e to the power anything has no dimensions and this T stands for time, the dimension of L by R also must be equal to time. So therefore dimension of L by R is also equal to time. Now substitute 2 and 3 in equation 1. So that becomes, if you take the power of 4, that becomes C square into L square. So therefore I will write this as a T to the power 4 into L by R has a dimension of T. So R by L will have a dimension of 1 by T. So this becomes 1 by T. So totally it becomes T to the power 3. So dimension of this quantity is only T to the power 3. That is option number D. Moving on to the next question. If the energy E, velocity V and force F are considered as fundamental quantities, then the dimensions of mass is. So instead of M, L and T, the fundamental quantities are given as a E, V and F. So we have to represent mass in terms of E, in terms of V and in terms of F. So using the method of dimensions, so mass let us take as proportional to E to the power X, V to the power Y and F to the power Z. So where E stands for energy, let us substitute mass has a dimension of only M. whereas energy has a dimension of m L2 t minus 2. Velocity has a dimension of Lt minus 1, and force has a dimension of mLt minus 2, but each term carries some power. So this has a power of x, power y, and power z. Now let us compare the powers on left hand side and right hand side. So here m has power 1, so x there is no term, and z, so x plus 0 plus z, that is 1z. Next, L has 0 power, here it has 2x, next y, and next it is minus plus 2z. Now t also on the left hand side has a power of 0, but here we have minus 2x plus minus y and minus 2z. So only we need to solve these equations. So after solving these equations, I am going to get x is equal to 1, y is equal to minus 2, and I am going to get z is equal to 0. So if you substitute these three values in the main equation, then it becomes e to the power 1, v to the power minus 2, and f to the power z. That gives you option 1 as a correct answer. Okay, moving on to the next question. A particle experiences a constant acceleration for 20 seconds after starting from rest. If it travels a distance of s1 in first 10 seconds and s2 in the next 10 seconds, then. So 4 options are given which relates s1 and s2. We have to select one right option. Now let us use the formula s is equal to ut plus half at squared. So the entire motion, out of the entire motion, only 2 parts are considered. The first part is 10 seconds, next part is also 10 seconds. So distance traveled in the first 10 seconds. U is anyway 0, it starts from rest. So I'll take that distance as a s1, that becomes half a into time is nothing but 10 square. So that will become totally 50a. Take it as a equation number 1. So as the particle continues, at the end of 10 seconds, its velocity will go on increasing. So at the end of 10 seconds, so velocity of the particles, v becomes u plus at. U was anyway 0, so v becomes equal to 10 into acceleration is unknown into 10. Let me take it as a equation 2. So the end velocity of the first part will be the initial velocity for the next part. So once again substituting the same formula, let me calculate the distance traveled in the next 10 seconds, s2, that will be u will be the end velocity of the first part, that is a into 10 into time is given 10 plus half a into 10 square, that is nothing but 150a. Equation 1. If you compare equation 1 and 2, so let me take it as equation 3. If you compare equation 1 and 3, this implies s2 is equal to 3 times s1. So if I continue to calculate like this, if I calculate s3, I'm going to get 5 times s1. So the ratio s1 is to s2 is to s3 will always be in 1:3:5 form. So the idea behind the problem is the distance traveled in first 10 seconds and distance traveled in the next 10 seconds will always be in the ratio of 1:3, or the distance traveled in the first 2 seconds and distance traveled in the next 2 seconds will always be in the ratio 1:3, or distance traveled in first 5 seconds and distance traveled in next 5 seconds will also be always be in the ratio of 1:3:5. So you can use this as a shortcut. So already we got an answer. S2 is 3 times S1. So that gives us option C. Next question 14. For a moving body at any instant of time, first option says so if the body is not moving, the acceleration is necessarily 0. If the body is not moving, the body may be spinning there itself, or body may be rotating. So if it is rotating, it will have a centripetal acceleration. First option is wrong. Second option says if the body is slowing down, the distance is negative. Distance can never be negative, distance is always positive. Second option is also wrong. Look at option C, if the body is slowing down, the retardation is negative. Now let's go back to equation option 4. If the displacement, velocity and acceleration at all time is known, we can find the displacement at any time. So option D is correct. Now come back to option C. It says that if the body is slowing down, the retardation is negative. So retardation is always negative of acceleration. If the body is slowing down in the positive direction, then we get acceleration is negative. If the body is traveling in the positive direction and if it slows down in the positive direction, then acceleration becomes negative. If the acceleration becomes negative, it's a reverse of acceleration, retardation will become positive. So option C is also wrong. Correct option is only option D. Next question 15. There are two statements given. Statement 1 says the displacement time graph of a body moving with uniform acceleration is a straight line. The second statement says this follows from S is equal to ut plus half at square. Suppose the body starts from rest, then the distance traveled by the body is only equal to half at square, or S is proportional to t square. So the graph between S and t must be a parabola. It can never be a straight line. So the statement 1 is wrong and statement 2 is correct. That is option D. Moving on to the next question. The displacement of a particle is given by y is equal to at plus bt square plus ct cube minus dt to the power 4. The initial velocity and acceleration are respectively. So velocity of the particle is given by differentiating the given equation. The given equation represents the displacement. So differentiate displacement with respect to time, we are going to get the velocity. So if I differentiate, this will become only a plus the second term is 2 times bt plus the third term will going to become 3 times ct square, and the last term is going to become 4 times dt cube. If I differentiate this equation one more time, I am going to get the acceleration. So therefore acceleration is nothing but dv divided by dt. That will become 2b plus 6 ct minus 12 dt square. But what is asked is initial velocity and initial acceleration. So initial stands for time t is equal to 0. So if I put time t is equal to 0, then velocity will become equal to a and acceleration is going to become 2b. Only a and 2b. That gives you option C. Going to the next question 17. The Vt graph of a moving object is given in the figure. The maximum acceleration is. So the graph is given somewhat like this. And it's a Vt graph, but what is asked is a maximum acceleration. So the graph has total 4 straight lines. So the acceleration will be maximum where the slope of the graph is maximum, because the slope of the Vt graph always gives you acceleration. So you have to find out where the slope is maximum. Now if you look at the time 30 second and 40 second, this line is more oriented towards the v-axis, so slope of only this line is maximum. So the maximum acceleration is possible only in this part. So that corresponds to velocity here 80, and here it corresponds to velocity 20. So therefore acceleration will be delta v divided by delta t, 80 minus 20 divided by 40 minus 30. That will give you 6 centimeter per second square. That is option number A. Okay. Going to the next question. A stone is dropped from a height h. Simultaneously, another stone is projected vertically up from a ground which reaches a height of 4h. The two stones cross each other after time. So let me take this is a ground, and the first stone is dropped downwards from a total height of h. I will take this height as a h. Now second stone is projected upwards, and it can reach a maximum height of 4h. And both the question says that both the motions take place simultaneously. When this is dropped, this is projected upwards. So when both of them are going to cross at some particular point, maybe over here. So let me take the first stone, travel a distance of h1, and the second stone travel a distance of h2 upwards. So that the total distance h1 plus h2 is going to become h. So for the first stone, distance traveled by it, h1 is only half gt square. For the second stone, when it reaches the maximum height, its velocity is going to become 0. So the maximum height traveled by any object that is projected from the ground will be u square by 2g. So this u square divided by 2g. So the total height traveled by the second stone is nothing but 4h. So if I rearrange the terms, I am going to get u is become equal to root of 8g into h. The meaning is that second stone is projected with a velocity of root of 8g into h. Now let us calculate what is the distance traveled by that second stone, h2. So therefore h2, that will be using the formula ut plus half at square. U is already here, root of 8gh into t minus half gt square. So but I already told you in the beginning, total height h1 plus h2, that will give the height from where the first stone is dropped, that is h. So if you substitute from equation 1 and from equation 2, substitute 1 and 2 in this equation. So this half gt square and minus half gt square is going to cancel out. You are going to get only 8gh into t, that is equal to h. So what is required is t, that will become h divided by root of 8g into h. H can be written as a root h into root h. 1 root h will cancel. So t is going to become root of h divided by 8g. That is option number D. Moving on to the next question. A man throws balls with the same speed vertically upwards, one after the other, at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are in the sky at any time? Take g is equal to 9.8 meter per second square. Now let us analyze this situation. Imagine there is a ball which is projected from the ground. So this ball goes up, reaches a maximum height, then it is going to come back. But after 2 seconds, one more ball is projected. After 2 seconds, one more ball is projected. So after irregular intervals of 2 seconds, the balls are projected up. Now suppose if the ball that is projected is going to reach the maximum height in 2 seconds, then when you project the third ball, this ball will come down and will reach the ground. That is only if the time upward is equal to time to come down is equal to 2 seconds. So this picture is correct only if the total time of flight TF is equal to 4 seconds. Then one ball will be in the player's hand, one ball is at the maximum height, then one more ball once again has reached the ground. So effectively there is only one ball in the air. So but the question says that there should be minimum 3 balls or more than 2 balls in the air. So what is required? The required thing is the time of flight. If it is 4 seconds, then this picture is correct. If the 3 balls has to be still in air, the time of flight should be more than 4 seconds. The meaning is that in 4 seconds, the first ball, this is the first ball, second ball and the third ball. So the first ball should not reach the ground in 4 seconds, it should be in the air. So the required quantity is the time of flight should be more than 4 seconds. And what is the formula for time of flight? Time of flight is nothing but 2u divided by g, and this quantity should be more than 4 seconds. So we have 2u by g is more than 4. So u should be equal to, or u should be more than 2g. So our u should be more than 2 into 9.8, or this is 19.6 meter per second. The meaning is that the projection velocity should be more than 19.6 meter per second. Then only there will be minimum of 3 balls in the air. So that gives you option A. Next question. A body thrown vertically upward with an initial velocity of u reaches a maximum height in 6 seconds. The ratio of distances traveled by the body in the first and the 7th second is given. Take g is equal to 10 meter per second square. So there is a body which is projected upwards. It reaches a maximum height in 6 seconds. So what about the time of ascent of the body? So time of ascent t should be equal to u by g. And this u by g is given as a 6 seconds. So this implies we have u is equal to 6g or 6 into 10, or the velocity with which it is projected will be 60 meter per second. Okay. Now let us calculate the distance traveled by the object in first second. So distance s1, we have distance traveled in the nth second. We have formula u minus g by 2, 2n minus 1. U already we calculated 60 minus, this is 10 by 2, 2 into 1 minus 1, that gives total, this is 2 minus 1, 5, 60 minus 5 is going to give us 55 meter. That is the distance traveled in the first second. Now the distance traveled in the 7th second is same as distance traveled in the first second of downward motion, because the body reaches the maximum height in 6 seconds. So therefore distance traveled in the 7th second is same as a distance traveled in the first second, but this is during downward motion. And for the downward motion, initial velocity at the top will become 0. So that becomes a u plus we have g by 2, 2n minus 1. So u is anyway 0 plus g is 10 by 2, 2 into 1 minus 1, that gives us 5 meter. So S7 is 5 meter, but what is asked is S1 by S7, that is 55 by 5, that gives you 11 is to 1. That is option D. Next question. The engine of a motorcycle can produce a maximum acceleration of 5 meter per second square. Its brakes can produce a maximum retardation of 10 meter per second square. What is the minimum time in which it can cover a distance of 1.5 kilometer? Now let us understand this problem using a VT graph. Let me plot a graph of velocity versus time. So since the acceleration is constant, the VT graph must be a straight line. So given initially the body accelerates at a rate of 5 meter per second square, then its deceleration is more. So the first graph, first straight line will be flatter, and the second straight line will be steeper. So finally the body is once again has to come to rest. So here it travels at a rate of, let me take alpha, and here it decelerates, let me take at a rate of beta. So the maximum velocity after this much of time is equal to v. So here this is the final velocity for the first part, and v also will be the initial velocity for the next part. So let me take this time as a time t1, this time as a time t2. Now since the initial velocity is 0, let me use the formula v is equal to u plus at. So for the first part, v can be written as a u is 0, a is nothing but alpha, time is t1. So that gives me time t1 is equal to v divided by alpha. Now look at the second part. The graph is more steeper because the retardation is almost a double. No, retardation is exactly double compared to the acceleration, and here final velocity is 0. So therefore we have 0 is equal to v. Initial velocity for the second part is v. So v minus b into t2. I have substituted minus beta, that is because it is a retardation. So this implies v is equal to b beta into t2, or this gives me t2 is equal to v divided by beta. So we have 2 times. So if I add both the times, I am going to get the total time. So therefore total time t is equal to t1 plus t2. So t1 v by alpha plus this is v divided by beta. V is common, I'll take it to the other side. So T divided by V is going to become 1 by alpha plus 1 by beta, or T by V is going to become alpha plus beta divided by alpha beta. Let me take the reciprocal, I'll rearrange the terms. V will be equal to alpha beta divided by alpha plus beta into time T. Let me take it as some equation 1. But what is asked is, what's the total distance traveled, what's the minimum distance traveled by the object at a rate of acceleration 6, at a rate of acceleration of 5, and at a retardation rate of 10. So if I take the area of this graph, it's a VT graph. If I calculate the area under the VT graph, that is going to give me the total displacement. So displacement S is nothing but area. So area, this is a square shape, so the area will be half into base into height. So this is half into base is nothing but total time T, into height is nothing but this, and that value is nothing but V. So this becomes half into T. V already I have calculated, so that becomes alpha beta divided by alpha plus beta into T, or the shortcut formula will give me half alpha beta divided by alpha plus beta into T square. So this is the shortcut formula that can be used. Okay, let us substitute the values. So total distance is given 1.5 kilometer, that will be 1500 meter. So that is half. Alpha is given 5, beta is 10, 5 plus 10 into T square. So if I solve this equation, I'm going to get T is equal to 30 seconds. That gives me option number D. Next question. A body A starts from rest with an acceleration of A1. After 2 seconds, another body B starts from rest with an acceleration of A2. They travel equal distance in the 5th second. Then the ratio of A1, A2 is. Let us use the formula. Distance traveled in the n second is U plus A by 2, 2n minus 1. So the question says the first body starts, it travels a total time for 5 seconds. Then after 2 seconds, the second body starts. So what the question says is, the distance traveled by the body in the 5th second is same as distance traveled by the second body in the 3rd second, because the second body only travels for 3 seconds. So therefore this becomes 0 plus A by 2. I'll take this as a A1. Here 2 into 5 minus 1. On the other side 0 plus A2 divided by 2. 2 into 3 minus 1. So 10, this is 9 times A1 should be equal to, this is 5 times A2. So therefore A1 by A2, the ratio A1 by A2 is going to become 5 is to 9. That is option B. The next question. The relation 3t is equal to root 3x plus 6 describes the displacement of a particle in one direction, where x is in meter and t is in second. The displacement when the velocity is 0 is. So the given equation gives us the relation between time and displacement, but what is asked is the velocity. So to find out velocity, first we must write the given equation in terms of displacement, then differentiate that equation, we are going to get a velocity. So let us write the equation. 3t is root of 3s plus 6. So root of 3x, that will be equal to 3t minus 6. So if I square on both the sides, I'm going to get 3t, here 9t square plus 36 minus 36t, or x is going to become equal to 3t square plus 12 minus 12t. So this is a relation that gives us the relation between displacement and time in the standard form. So if I differentiate this equation, I'm going to get velocity dx divided by dt. So that will become 6t minus 12. Now what is asked is the displacement when the velocity becomes 0. So let's put velocity is equal to 0. So 6t minus 12. So that gives me t 6t is equal to 12, or t is equal to 2 seconds. Now let's substitute this 2 seconds in the equation of displacement. So x becomes equal to 3 into 2 square plus 12 minus 12 into 2, or x is going to become 0, or the displacement will be 0. That is first option. Next question. A car starts from rest, accelerates at a rate of f through a distance s, then continues at a constant speed for some time t, and then decelerates at a rate of f by 2 to come to rest. If the total distance traversed is 15s, then, okay, let us picturize the problem. So the body travels from A to B and it accelerates from A to B, but from B to C it moves with a constant velocity, and from C to D it decelerates, and finally it comes to rest at D. This total distance is given as a 15s. And the question also says that the distance A to B is s, the distance B to C is unknown, I'll take it as a x. Distance C to D is also unknown, I'll take it as a y. But if I add all the distances, s plus x plus y, I'm going to get a total 15s. Now let's calculate what is the velocity of the particle at point B. So at B, velocity at B will be root of 2a into s. A stands for acceleration, and acceleration from A to B is given as a f, 2f into s. So the distance traveled by the body from B to C, the body moves from B to C with a velocity vb. So therefore distance x can be written as a velocity vb into time t. So that is unknown, I'll take it as some equation 1. So let me substitute for velocity. So x is nothing but root of 2f into s into time t. Let me take it as equation number 1. But the velocity at B and velocity at C is the same, because the body is moving with a constant velocity from B to C. So therefore at C, velocity at C and velocity at B will be same, that is root of 2f into s. So therefore this 2f into s is the initial velocity at point C. So the body is decelerating from C to D. I can calculate what is the distance D. So final velocity for this part will be 0. So therefore distance D, that will be nothing but v squared divided by 2a, and that velocity is nothing but vc. So therefore that will be equal to vc is already here, root of 2f into s the whole square divided by 2 times. Now acceleration from C to D is given, that is f by 2. F by 2. So let's calculate how much is this value. That will give me, if you solve for this distance is going to become 2s. Now if I add x plus y plus s, that total should be equal to 15s. So s plus x plus y, that is 15s. So s plus x is already calculated. As a root of 2fs into t, plus y is already calculated as a 2s, that is 15s. So therefore root of 2fs into t, that will become, this is 3s, take it to the other side, that becomes 12s. Now square on both the sides, 2fs into t square, that will become 144 s square. 1 s is going to cancel. So what is asked is the distance s. So distance s, that becomes 1 by 72 times f into t square. That is option number 4. Next question. The acceleration a in meter per second square of a particle is given by a is equal to 3t square plus 2t plus 2, where t is in second. If the particle starts out with a velocity 2 meter per second, then the velocity at the end of 2 seconds is. So the given equation is a is equal to 3t square plus 2t plus 2. So this is not an equation of a constant acceleration, it's a acceleration which depends on time. But we have to find out the velocity, so we have to differentiate this equation. Acceleration is a function of time. Let me write this as a dv divided by dt, that is 3t square plus 2t plus 2. So dv, that will be equal to 3t square plus 2t plus 2 dt. Let me integrate on both the sides. Now you have to carefully substitute the limits for integration. So here the time has a limit from 0 to 2 seconds, whereas the velocity, initial velocity is given 2, final velocity is unknown. That final velocity has to be calculated. So this becomes v minus 2, that is equal to, on the other side, this becomes a t cube plus t square plus 2t from 0 to 2, or v minus 2 will be equal to, now substitute the upper limit, that becomes 2 cube, that is nothing but 8 plus 4 plus 2 into 2. So v together becomes, take 2 to the other side, 8 plus 4 is 12, 12 plus 4 will give you 16, 16 plus 2 is going to give you total 18 meter per second. That is option B. Question number 26. The given graph shows the variation of velocity with displacement. Which one of the graphs given below correctly represent the variation of acceleration with the time? So the given graph is a graph of velocity versus displacement, and this graph is a straight line. So the given graph has it's a straight line. So let us use the equation of a straight line using y is equal to mx plus c. So let us use this equation. Instead of y, we have v, and this initial value is given in the question as a v naught. So v becomes equal to minus mx plus, here c is nothing but a y-intercept, that is nothing but v naught. And why this become minus is because the slope of the graph is negative. The graph is decreasing, so the slope must be negative. So it is y is equal to minus mx plus c. Let me take it as a equation 1. Now let us differentiate this equation. dv by dt, that is equal to minus m dx divided by dt. The next quantity will become 0. It's a constant, it will become 0. So dv by dt is nothing but a acceleration. So acceleration has become minus m dv by dt is nothing but a v. Let me substitute from equation 1. So a becomes equal to minus m v. We have minus mx plus v naught, or equation of acceleration becomes m square x minus m into v naught. Once again, this is the equation of a straight line. So this second part is a constant, and that constant has a negative intercept, whereas if you look at this first part, this is nothing but a slope. So the slope is positive, y-intercept is a negative. So that is possible only in option number 1. Next, question number 27. When an object is shot from the bottom of a long smooth inclined plane kept at an angle of 60 degree with the horizontal, it can travel a distance of x1 along the plane. But when the inclination is decreased to 30 degree, the same object is shot with the same velocity, it can travel a distance of x2. Then the ratio x1 is to x2 is. So imagine one inclined plane, inclined at an angle theta, and from the bottom one object is shot up with some velocity u. So here the motion is taking place only under gravity. So g is acting vertically downwards. So let's resolve this g into two components. So here this becomes theta. So this side is g cos theta, and this component, that will be equal to g sin theta. So the component of acceleration due to gravity acting along the motion of this direction of motion of this object is only g sin theta. So when the object is shot up, after traveling certain distance, it will stop. So let us use the formula of a stopping distance. So stopping distance is s is nothing but u square divided by 2a. So this is nothing but u square divided by 2 times. So acceleration along this is only g sin theta, or u, in both the cases u is same, 2 is constant, g is constant, or distance is inversely proportional to sin theta. So therefore distance 1 divided by distance 2. In the question it is mentioned as a x1, here it is mentioned x2. So this will be only sin theta 2 divided by sin theta 1, or this is sin 30 divided by sin 60. That will give you 1 by 2, root 3 by 2. That gives you 1 divided by root 3. So 1 is to root 3 is option C. Okay, let us move to question number 28. A person traveling in a straight line moves with a constant velocity v1 for a certain distance x and with a constant velocity v2 for the next equal distance. The average velocity v is given by the relation. So this question was appeared in a NEET exam. Let us solve it. So the total traveled distance is divided into two parts. First part is x, second part is also x. What is asked is the average velocity between these two positions. So I can write here time t1 is equal to distance x divided by v1, and time t2 can be written as a distance x divided by v2. But what is asked is average speed. So average speed, V average, is nothing but total distance, that is x plus x divided by total time t1 plus t2. So this becomes 2x divided by, this is x by v1 plus x by v2, or V average becomes equal to 2 divided by 1 by v1 plus 1 by v2. So let us solve this. So rearrange the terms. We have V average divided by 2, that will become 1 divided by, we have v1 plus v2, and the common LCM is going to go to numerator. So let us invert the equation on both the sides. So when you invert the equation on both the sides, that becomes 2 divided by V average, that will become equal to v1 plus v2 divided by v1 v2, or that is going to become 1 by v1 plus 1 by v2. Here it becomes 2 divided by V average, that is nothing but option number 2. Let us move to the next question, 29. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. So there is an escalator, here is a ground, and there is a ground, here is maybe a first floor, and there is a girl. She reaches the bottom of the escalator and she finds that the escalator is not working. So she just walks up the escalator, and escalator steps are not at all moving. So the velocity of her is with respect to now the escalator. So therefore velocity of the girl with respect to escalator, I'll write V velocity of Preeti with respect to escalator, VPE, that is nothing but total distance divided by some time, that is given in the question as a T1. So this distance is nothing but D. And the second situation is given. The girl, as per the statement of the question, on the other days, if she remains stationary on the moving escalator, then she reaches up in time T2. So she is not moving, only escalator takes her up. That means her velocity is now with respect to the ground. So velocity of girl with respect to the ground, I'll write velocity of Preeti with respect to the ground. That is nothing but distance traveled is once again same, and time is mentioned in the question as a T2. Now let us use the concept of relative velocity. So velocity of Preeti with respect to the escalator, that should be equal to velocity of Preeti minus velocity of escalator. But here this velocity is measured with respect to the ground, and here this velocity is also measured with respect to the ground. So let us rearrange the terms. So velocity of Preeti with respect to the ground, that will become velocity of Preeti with respect to the escalator plus velocity of escalator with respect to the ground. So let me take this velocity is nothing but distance divided by, let me imagine this takes place at a time t, and here this is given as a distance d divided by t1 plus this time is given as a d divided by time 2. So d is going to cancel on all the sides. We are going to get 1 by t is equal to 1 by t1 plus 1 by t2, or t will be equal to t1 t2 divided by t1 plus t2. That is option B. Moving on to the next question. Two cars P and Q start from a point at the same time in the straight line, and their positions are represented by xp is equal to at plus bt square and xq is equal to ft minus t square. At what time do the cars have same velocity? So what is given is a velocity of the first car is equal to velocity of the second car. So given information is only the positions. You differentiate the positions, you are going to get the velocity. So differentiation of first, directly I will write a plus 2 bt, and differentiation of second term is going to get f minus 2t. So rearrange the terms. So take 2t common. This becomes b plus 1. On the other side, it becomes f minus a. So t will be equal to f minus a divided by 2 times b plus 1. That is option D. Question number 31. If the velocity of a particle is given by v is equal to at plus bt square, where a and b are constants, then the distance travelled by it between 1 second and 2 seconds is. So equation of velocity is given at plus bt square, but asked is a displacement. So you have to integrate this equation to get the displacement. So let me write velocity as a dx by dt. So this becomes at plus bt square. So rearrange the terms. Dx is going to become at plus bt square into dt. Now integrate on both the sides. So this is from 0 to x. This is given from time 1 second to second. So this integration is with respect to time. This integration is with respect to position. So integration of dx will give you x minus 0. On the other side, it will give at square divided by 2 plus bt cube divided by 3 between limits 1 and 2. So x is going to become, substitute the limits, a by 2 into 2 square plus b by 3 into 2 cube minus we have a by 2 plus b by 3. You solve them, we are going to get 3 by 2 a plus 7 by 3 b. That is option number A. Next, question 32. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to equation v is equal to beta x to the power minus 2n, where beta and n are constant and x is the position of the particle. The acceleration of the particle as a function of x is given by. So we have v is equal to, that is given in the question, beta x to the power minus 2n. We are supposed to find out the acceleration. So let me write, let me just, but this velocity is never a function of time. Most of the cases, the equations are given in standard form where velocity is function of time. But here is a velocity is a function of displacement. Velocity is a function of displacement. So we have to do some adjustments. We have to bring the time term into our equation. So I'll differentiate this equation with respect to displacement. So that becomes minus 2n beta x to the power minus 2n minus 1. So dv, I will multiply with dt, divide with dt. That becomes dv by dt into dt divided by dx. That is minus 2n beta x to the power minus 2n minus 1. But dv by dt is nothing but acceleration. dt by dx is going to give me reciprocal of velocity 1 by v. So this is equal to minus 2n beta x to the power minus 2n minus 1. Take velocity to the other side. A is equal to minus 2n beta x to the power minus 2n minus 1. Velocity is already given here, so that I'll write here directly, beta x to the power minus 2n. So acceleration is going to become minus 2n beta square x to the power minus 4n minus 1. That gives you option number 4. Next question 33. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, in the next 5 seconds and the next 5 seconds respectively. The relation between h1, h2 and h3 is. So this question can easily be solved. I already explained you the shortcut in question number 13. It is same as the question number 13. The distance travelled will be in the ratio h1 is to h2 is to h3 should be equal to 1 is to 3 is to 5, and that is option D. Moving on to the question 34. The velocity time graph for two bodies A and B are as shown. Then the acceleration of A and acceleration of B are in the ratio. So given graph is a VT graph and there are two straight lines B and A. This makes an angle of 25 degree with the time axis, and this straight line makes an angle of 40 degree with the velocity axis. So what is asked is the acceleration, and acceleration is nothing but slope, and slope is always given as a tan theta. So therefore slope, the slope of the first graph is tan of 25 degree, and this total angle will be, this is 40 out of 90, 40 goes, remaining is 50. So tan 25 and tan 50 degree, that is option B. Question 35. A car moves from A to B with a speed of 30 km per hour and from B to A with a speed of 20 km per hour. What is the average speed of the car? So if you look at the problem, the distance travelled from A to B is same as the distance travelled from B to A. So it's a motion has total 2 parts, but the distance in both the parts is same. So we'll use a direct shortcut formula. Average velocity will be equal to 2 times V1 V2 divided by V1 plus V2. So that will be 2 into first velocity is given 30, second velocity is given 20. So divide by 30 plus 20. So we are going to end up with 24 km per hour. That is option B. Next question 36. A body starts from rest and moves with a constant acceleration 40 seconds. It travels a distance of x1 in the first half of time and x2 in the next half of time. Then you have to find the relation between the distance travelled in the first part and the distance travelled in the second part. I already told you in question number 13, you can use the same concept because the time in the first part is same as the time in the second part. So if the time in the first part is same as the time in the second part, then the distances are always in the ratio x1 is to x2 will be always in the ratio 1 is to 3. So that means it is option A is option C. Next question 37. A particle shows distance time curve as shown in the figure. The maximum instantaneous velocity of the particle around the point is. So graph is a displacement time graph, and instantaneous velocity at any time can be calculated as a dx by dt, or also it is given as a tan theta, or it can also be seen by understanding the slope. So if the slope is more, the instantaneous velocity is more. So if you look at the part 0 to P, that's the first part, it has some slope. If you look at the next part, it is little bit bent up to Q. So slope of this part is less. Now if you look at from Q to R is more oriented towards the distance axis, and the last part is a curve. So if you look at the part from Q to R, this part has a maximum slope. If this part has a maximum slope, then the maximum instantaneous velocity is possible at point R. So this part we take as R, this part is Q, and this part is P. So that means right option is option C. Next, the 3 different objects M1, M2 and M3 are allowed to fall from rest and from the same point O along 3 different frictionless paths. The speeds of 3 objects on reaching the ground will be in the ratio. So if you read the question correctly, the different objects have different masses, but there is information given in the question. It says that there is no friction and all are allowed to fall from the same height. So if there is no friction and if all the objects are allowed to fall from the same height, then velocity on reaching the ground is nothing but root of 2g into h, and it depends on only height, and height is same. So since there is no friction, the velocity upon reaching the ground will always be in the same ratio. So the answer will be option B. Next, question 39. A stone is projected vertically up from the bottom of a water tank. Assuming no water resistance, it will go up and come down in the same time. But if the water drag is present, then the time it takes to go up, T up, and the time it takes to come down is T down, is related as. Now consider this object while moving up. So while moving up, the weight of the object acts downwards, that is mg, and since it is moving up, the drag force F drag, or I'll simply write it as a drag force, that also acts in the opposite direction of always motion. Body is moving upwards, so drag force must be acting downwards. So apply Newton's object is moving up, so apply the Newton's second law. So we have m into a is equal to mg plus f, or acceleration becomes mg plus f divided by m. This is while going up, so I'll write this acceleration as a up, take it as a equation 1. Now suppose the same object is going down. Weight always acts vertically downwards, mg, and since the motion is downwards, drag force will be upwards, that is upwards. So once again apply the Newton's second law, m into a down, that should be equal to, that is mg minus f, or acceleration down will become mg minus f divided by m, some equation 2. Now if you compare equation 1 and 2, acceleration upward is more than acceleration downward. But this is not asked. What is asked is the relation between time to go up and time to come down. So the time to go up, T up, is proportional to u divided by acceleration. Since time is inversely proportional to acceleration, so time up must be less than time to come down. That gives you option C as the right choice. 40. Which of the following velocity time graph shows a realistic situation for a body in motion? So all the 4 graphs are nothing but a velocity time graph. So at a given time, there should be only one value for the velocity. If you look at option 1, take any one time, there are 2 values for velocity. Option 1 is wrong. Look at option C. If you take any one time, there is a possibility of having 2 values of velocity. Look at option D. There also, for a given time, there are 2 values of velocity. Only option B is a right choice because at a given time, it has only one value of velocity. Option B will be correct. Next. In an experiment, the percentage error occurred in the measurement of physical quantities A, B, C, and D are 1%, 2%, 3%, and 4% respectively. Then the maximum percentage error in the measurement of x, where x is given as a square, b to the power half, c to the power 1/3, and d to the power 3 will be. So already I told you in question number 4, use the same formula of product rule, quotient rule, and the power rule. The solution is already displayed. The right choice will be option B. Next, question 42. A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 millimeter and 0 of circular scale division coincides with the 25 divisions above reference level. If screw gauge has a zero error of minus 0.004 centimeter, then correct diameter of the ball is. So we have formula for the total reading, that is main scale reading plus we have circular scale reading into least count. minus 0 error. So main scale reading is given 0.5 plus, it is 5 millimeter, so I am writing it in centimeter, that becomes 0.5 millimeter. So circular scale is given 25 into least count is given 0.001 minus 0 error is given minus of 0.004. So if we solve this, we are going to get 0.529 centimeter, that is option 4. Question 43. A physical quantity of the dimension of length that can be formed out of C, G and E square by 4 pi epsilon naught is, where C is the velocity of light, G is the universal gravitational constant and E is the charge. So we have to find a physical quantity which has a dimension of length that should be proportional to, we have C to the power x, G to the power y, and we have a quantity E squared divided by 4 pi epsilon naught to the power z. Let us substitute the dimensions of the left hand side and right hand side. L has a dimension of length, C is nothing but a velocity, it has a dimension of Lt minus 1. Universal gravitational constant has a dimension of m minus 1, L3 and T minus 2. And the last quantity, this E squared by 4 pi epsilon naught has a dimension of m L cube T minus 2, along with their powers here x, y and z. Now compare the powers on all the sides. We get 0 is equal to, we have minus y plus z. Then we get powers of length will be 1 is equal to x plus 3y plus 3z, and dimension of time is 0 on the left hand side. On the right hand side it becomes minus x minus 2y minus 2z. If you solve this, so we are going to end up with x is equal to minus 2, y is equal to half, and z is also equal to half. That gives you first option as a right choice. Moving on to the next question, 44. A motorboat covers a given distance in 6 hours moving downstream on a river. It covers the same distance in 10 hours moving upstream. The time it takes to cover the same distance in still water is. So there is a boat and here is a water flowing. So while moving downstream, the meaning of downstream is direction of motion of boat and direction of water both are same. So boat travels in the same direction as that of water, both are in the same direction. So the effective velocity will be Vb plus Vw, and while moving downstream, the total time taken T1, this will be distance divided by velocity of boat plus velocity of water, and this time is given as a 6 hours. Now when the boat goes upstream, upstream means the direction of motion of boat is in the opposite direction of motion of water. So that time the effective velocity will be equal to Vb minus Vw. So upstream time T2, this will be equal to distance divided by Vb minus Vw. This total time is given as a 10. Okay, let's take the ratio. 6 by 10 is equal to Vb minus Vw divided by Vb plus Vw. So if we solve, cross multiply and solve, we are going to get Vb is equal to 4 times V of water. Now substitute that value in the first equation. So that becomes distance divided by Vb plus, instead of velocity of water I can write Vb divided by 4. That is nothing but 6. So distance divided by Vb, I am going to get this will be 30 divided by 4. So distance by velocity is nothing but a time. 30 by 4 is going to give 7.5 hours. That is option B. Next, question 45. What is the angle between instantaneous displacement and acceleration during retardation? Since it is a retarding motion, displacement and acceleration always must be in the opposite direction. So the right choice is option D. Question 46. Unit of self-inductance is. So we have EMF induced in a inductor is equal to L di divided by dt. So we can write L is equal to E into dt divided by di. So E stands for EMF, and EMF is defined as a work by unit charge. So this is nothing but work per charge into this is time divided by current. So unit of work is joule, unit of time is second, divided by unit of charge is coulomb, and unit of current is ampere. So the right choice is a second option. 47. Of the following quantities, which one has the dimensions different from the remaining three? Now look at the first quantity A. It is given as a energy per unit volume. So energy has a dimensions m L2 T minus 2, and volume has a dimensions of L cube. So the final dimension of this becomes m L minus 1 T minus 2. The second quantity is given as a force per unit area. So force has a dimensions m L T minus 2 divided by area has a dimension L2. So if we substitute, we are going to end up with m L1 minus 1 T minus 2. The third quantity is given as a product of voltage and charge per unit volume. So voltage can also be written as a work done per unit charge. So this is work by charge into, we have charge into volume. So charge is going to cancel. So the unit must be only for work and volume. Work and energy both have same dimensions. So we have m L square T minus 2 divided by volume. This will be L3. So finally we are going to end up m L minus 1 T minus 2. The last quantity is given as a angular momentum per unit mass. Let us directly substitute the dimensions. Angular momentum has m L square T minus 1 divided by mass. So this last quantity will have a dimensions m0, L, 2 and T minus 1. So this last quantity has a dimension which is different than the other three. So the right option is option D. Question 48. A body travels uniformly a distance of 13.8 plus or minus 0.2 meter in a time 4 plus or minus 0.3 second. The velocity of the body within error limits is. So let us list out what is given. Distance traveled by the body is given 13.8 plus or minus 0.2 meter, and time it takes to cover this distance is given as a 4 plus or minus 0.3 second. But what is asked is a velocity along with the errors. So velocity is nothing but distance divided by time. So here we directly cannot substitute. We cannot take the ratio of distance by time, because we can take the ratio of the first quantity, that is nothing but a physical quantity, that we can take 13.8 by 4, but the next part is called as an error. So this error is in meter, this error is in seconds. So that ratio cannot be taken. So only possibility is we have to convert everything first into percentage. Convert the errors first into percentage, get the error of velocity also in percentage, then convert back into meter per second. Directly if you take it, you will get a wrong answer. So let's first calculate that in percentage. In percentage, S can be calculated as a 13.8 plus or minus. How to calculate percentage is delta S by S into 100. So this becomes 0.2 divided by 13.8 into 100. So S becomes 13.8 plus or minus, this is 1.4%. Let me take it as a equation number 1. Now similarly calculate time in percentage. Time will be 4 plus or minus, this is error divided by the original value 4 into 100%. So this time becomes 4 plus or minus 7. We get 5%. Equation 2. Now we can take the ratio of S by T to find out the velocity. So V becomes equal to S by T, that is 13.8 plus or minus 1.4% divided by, we have 4 plus or minus 7.5%. So if we do this calculation, we are going to get V is equal to 13.8 by 4 will give us 3.45 plus or minus. Errors are always added, so 7.5 plus 1.4 will give us 8.9%. Now the velocity is in percentage, but none of the options match because this error once again is converted back into meter per second. That means we have to convert the 8.9% of 3.45. So what is the 8.9% of 3.45 is 8.9 into 3.45 into 100. If you calculate this, we are going to get to 0.307. So if you round it off to 0.3. So therefore velocity is going to become only 3.45 plus or minus 0.3 meter per second. That gives you correct option as option B. Question 49. Given E, M, L and G denote energy, mass, angular momentum and gravitational constant respectively, then the dimension of E L square divided by M5 G2R. So let's substitute. Given E L square divided by, we have M to the power 5 and G to the power 2. So directly substitute the dimensions. Dimension of energy is M L2 T minus 2. L is given as an angular momentum, that is M L2 T minus 1, once again given as a power of 2 divided by dimension of mass is M to the power 5 and dimension of universal gravitational constant will be M minus 1, L 3 and T minus 2 the whole square. So solve this, we are going to end up with M0, L0 and T0. That's a option which should not have any dimension. So out of the given options A, B, C and D, only angle is a dimensionless quantity. So right option is option A. Question 50. The length, breadth and thickness of a block are given by L is equal to 12 centimeter, B is equal to 6 centimeter, T is equal to 2.45 centimeter. The volume of the block according to the idea of significant figures should be. So volume is calculated using the formula length into breadth into height. So length is given as a 12 centimeter, breadth is given as a 6 centimeter and height is given as a 2.45 centimeter. So if we take the product of this, we are going to get 176.4 centimeter cube. But the answer is written as in the standard form, that is 1 digit before decimal point and remaining is given as a power to the 10. So every option has a 10 to the power 2. That means I should write here 1.764 into 10 to the power 2. But none of the options are like this. We have to do some rounding off here. So if you look at length, breadth and height, out of these three numbers, the breadth has a minimum significant figures, that is only 1. So we have to round it off to only one significant figure. So this 4 you can neglect. So you can write it as only 1.76. But 6 is more than 5, so that the previous will be incremented. That becomes 1.8 into 10 to the power 2. And since 8 is once again more than 5, we have to increment the previous 2 into 10 to the power 2. Now this number has only one significant figure, that is the 2. So hence your answer become 2 into 10 to the power 2 centimeter cube. That is option B. Next, question 51. A body has the speeds v, 2v and 3v in first 1/3 of distance s, second 1/3 of distance s and third 1/3 of distance s respectively. Its average speed will be. So we have the formula directly. Let's use the shortcut formula. V average is total distance divided by total time, t1 plus t2 plus t3. So the total distance is nothing but x. The time can be written as a t1 can be written as a distance in the first part divided by velocity. Distance in the first part is x by 3 plus velocity. Distance in the next part is also x by 3, but velocity is given as a 2v plus in the next third part is also distance is x by 3 and velocity is nothing but 3v. So if you solve this, you are going to end up with 18 by 11 v. That is option C. Next, question 52. A car is traveling on a straight level road with a uniform speed of 60 km per hour. It is followed by another car B, which is moving with a speed of 70 km per hour. When the distance between them is 2.5 km, the car B is given a deceleration of 20 km per hour square. After how much time will B catch up with A? Let us picturize the problem. There is car A and here we have car B. Both are traveling in the same direction, and when the distance between them becomes 2.5 km, this is given a deceleration. That means it is going to slow down. So when this slows down, the car A will move more towards B, and at one particular point, let me take that point as a P, both car B and car A are going to meet each other. So before meeting each other, B travels a distance of BP, whereas A travels a total distance of A to P. Or in other words, when both the cars meet at this point, the position of B and position of A both become same, or the relative distance between B and A will become 0. So distance between B minus distance between A, this is going to become 0. So XB is same as a XA. So whereas XB is nothing but distance traveled from B to P. So that distance can be calculated by using the formula ut plus half at square. So its initial velocity is 70 into t minus, why it is minus? Because it is a deceleration. Half into deceleration value is given 20 into t square. On the other side, it is first car, that is car A, it is not given any deceleration. It moves with a constant velocity, that is 60 only, but it is going to travel a distance of 2.5 km plus the extra distance BP. So that will be total 2.5 km plus the remaining distance can be calculated, it product of velocity into time. So if we solve this equation, we are going to get 10 t square minus 10t plus 2.5, that is equal to 0, or it is t square minus t plus 0.25 is equal to 0, or you substitute and take the roots of t, we are going to get 0.5 hour. That is option B. Next, question 53. The speed of a body moving with uniform acceleration is u. This speed is doubled while covering a distance of s. When it covers an additional distance of s, its speed would become. Okay, there is a body that is moving with uniform acceleration, and after covering certain distance, its velocity becomes a double. Here its velocity is u, and here its velocity becomes 2u upon traveling a total distance of s. As per the given information in the question, it travels a furthermore distance of s, and at the end of that, its speed is going to become how much? What will be the speed over here? So look at the first part. we'll use the formula v square is equal to u square plus 2a into s. So here final velocity for the first part is nothing but 2u square is equal to u square plus 2a into s, or we have 2a into s becomes equal to 3u square. For the next part, the final velocity is v. Once again, we'll use the same formula, v square is equal to, we have u square, that is nothing but 2u plus 2a into s. So instead of 2a into s, I can substitute for it as a 3u square. So we have total 4u square plus we have 3u square. So together it becomes 7u square. So take the square root on both the sides. This becomes root 7u. That is option D. Next, question number 54. Two trains, one of length 100 meter and another of length 125 meter, are moving in mutually opposite directions along parallel lines, meet each other, each with a speed of 10 meter per second. If their acceleration is 0.3 meter per second square and 0.2 meter per second square respectively, then the time they take to pass each other will be. So we have to take care of the relative concepts here. So there are two trains, both are moving in the opposite direction. So the effective velocity or their relative velocity will be the sum of individual velocities. So that will become 10 plus 10, that is 20 meter per second. Similarly, both are accelerating in opposite direction. So let's calculate what is the relative acceleration. A, that also will be the summation of acceleration of individual trains, 0.3 plus 0.2, that is 0.5 meter per second square. Now let us use the distance formula, that is s is equal to ut plus half at square. So relative velocity v, that is you can write v or u, doesn't matter, u. So this u is 20 into t plus half, acceleration is there 0.5 into t square. Now substitute, this becomes equal to, on the other side the distance s is nothing but the total length of both the trains. So total length of both the trains is 100 meter and 125 meter. Let's solve this equation. We are going to get 0.5 t square plus 40t minus 450, that's equal to 0. Let's find the root of t. So t will be equal to minus 40 plus or minus root of, we have 40 square, that is 1600 plus 4 into 0.005 into 450, entire thing divided by 1. So we are going to get t is equal to minus 40 plus or minus 50. So we are going to get two roots. One is plus 10 second, or we get minus 10 second. So right choice will be the positive answer. T is equal to 10 second, that is option B. Yes. Next, question 55. A body starts from rest with uniform acceleration. If its velocity after n seconds is v, then its displacement in the last 2 seconds is. So the body starts from rest. So initial velocity is 0. So final velocity after n seconds. After n seconds, final velocity will be 0 plus a into n. So this implies acceleration of the body will be equal to v divided by n. So the distance travelled after n seconds will be half a into n square. Let me take it as a equation 1. So let us calculate what is the distance travelled after n minus 2 seconds. After n minus 2 seconds, let me take the distance travelled total as a s dash half a n minus 2 the whole square, that is equation 2. Now let us calculate the distance travelled in last 2 seconds, that is subtract the distance travelled in n minus 2 seconds from distance travelled in n seconds. So delta s this will be equal to S dash, sorry, S minus S dash, that will become half an square minus, we have half a into n minus 2 square. So that becomes half an square minus, we have half a, this is n square plus 4 minus 4n. Now multiply inside, we get half n square minus half n square. So this minus and this minus, that will become minus 2a, then minus of minus will become plus, that will become 2n. So these two quantities cancel, remaining is 2 is common. There's a term that is missing here, that is n. So sorry, that is a. So 2a is common, that will give me n minus 1. So 2 into acceleration we found out here, substitute v by n into n minus 1. So 2v n minus 1 divided by n, that gives you option 4. Yes. Next question 56. A particle is projected with velocity v0 along x-axis. The deceleration on the particle is proportional to the square of the distance from the origin, that is a is equal to alpha x square. The distance at which the particle stops is. So acceleration of a particle, a is nothing but dv divided by dt. But if you look at the question, acceleration is given as a function of x. It is not given as a function of time. So we have to bring time into picture. So let me write this as a dv by dx into dx by dt. Just multiply and divide with the dx. So this is going to become dv by dx as it is, into dx by dt is going to give me velocity. So acceleration is already given, alpha into x square, but the question says there is a word retardation. So, and since there is a word retardation, that acceleration is a negative. So minus alpha into x square, that should be equal to dv by dx into v. So let me take dx to the other side. So that becomes v dv, that becomes equal to minus alpha x squared into dx. Now let's integrate on both the sides. Integration of v dv, on the other side minus of alpha, integration of x squared dx. You have to carefully substitute the limits. So here it's a integration with respect to dv, and initial velocity is given v0, final velocity is 0 because the object is going to stop somewhere. On the other side, it's an integration with respect to distance. So initial, it starts from origin somewhere, we don't know, and final distance, let's take it as some s. So integration, this will be v squared by 2 from v0 to 0. On the other side, minus of alpha, this will become x cube by 3 from 0 to some value s. So I'll change the limits here, I'll interchange the limits. This will become minus, this minus and this minus will cancel. So v squared by 2, let me write it as from 0 to v0. So on the other side, alpha, we have x cube divided by 3 from 0 to some value s. Now let us substitute the limits. That becomes v0 square by 2. On the other side, alpha, here 1/3 remains, s cube. But what is asked is the value of s. So rearrange the terms, you get 3 times v0 square divided by 2 times alpha will be equal to s cube. Now take the cube root of this, 3 times v0 square divided by 2 times alpha. The cube root, that is going to become s. That is nothing but option number 4. Next, question 57. A ball is thrown vertically upwards. Which of the following plots represent the speed time graph of the ball during its flight if the air resistance is ignored. So if the ball is thrown up and if the air resistance is ignored, with what velocity it is thrown, that is u, it goes up, and with the same velocity it is going to reach the hands of the observer, that is also u. So initial value and final value must be same, and since there is no air resistance, the slope of the VT graph also must be same. Slope of the VT graph must be same, so that gives you only option as a option C. The acceleration time graph of a body is shown. The corresponding velocity time graph of the same body is. So this is the acceleration time graph. Okay, let's plot the velocity time graph. Now if you look at this part, the acceleration is constant. So since acceleration is constant, velocity should increase at a constant rate. Next, from here to here, acceleration is 0, so the velocity must be constant. Next, from here till here, the acceleration is once again constant, and that is also positive, so the velocity once again is going to increase. So the correct graph is option C. Next, question 59. A wheel of radius 1 meter rolls forward half a revolution on a horizontal ground. The magnitude of the displacement of the point of the wheel initially in contact with the ground is. So consider a wheel, and here the bottommost point of this wheel A is in contact with the ground, and given that this wheel rotates for a half of revolution and it comes to a new position. So when it revolves for half of revolution, the point A, which is at the bottommost position, now reaches the topmost position. I'll call now this point as a A dash. So the point is shifted from A to A dash. So this displacement A to A dash has to be found out. Now the given information is the radius of this is r, so the diameter total will be 2r. So this distance becomes 2r. Now this length from A to point P, that is nothing but distance travelled by the circumference of this circle. So since the revolution is half, the circumference that is traversed on this line is only half of the perimeter, half of the circumference. So half of the circumference means it is 2 pi r by 2, or it is only pi r. So now we have the length AP, we know P to A dash. Use the Pythagoras theorem, use A to A dash, that will be root of pi r the whole square plus 2r the whole square. But since in the question radius is given as a 1 meter, we are going to get only pi square plus 4 under root. Option C. Next, question 60. Which of the following options is correct for the object having straight line motion represented by the following graph? The option A says the object moves with constant increasing velocity from O to A, and then it moves with constant velocity. That will be wrong. That is not possible in this graph. Look at the second option. It says velocity of the object increases uniformly. It is not going to increase uniformly because the entire graph has so many straight lines and there is no continuous breaks. They are continuous joining straight lines. So there is no smooth change from one transition to another transition. So the second option is also wrong. Look at the fourth option. It says graph shown is impossible. The graph shown is possible. So option D is wrong. Look at option C. It says average velocity is 0. So if average velocity has to be 0, then average the distance travelled between initial position and final position, that must be 0, or the displacement must be 0. If you look at the graph, along x-axis we have the displacement and along y-axis we have a time. It is not a ST graph, it is a TS graph. So the body starts from here, it goes to different positions, finally it reaches the same position. That means the displacement is 0. If the displacement is 0, the average velocity is also 0. Correct option is option C.